Yes, hello, welcome to all. Today we are going to start new topics. Transpose of a matrix. Transpose of a matrix. We can interchange the columns, all columns into rows, and rows into columns. Let us suppose we generally represent transpose by a dash. Suppose if we have a matrix of orders M cross n. This is the general term Aij. Aij element of this matrix A whose order is M cross n. If I find out the transpose of this matrix, so we have here M rows and n columns. It will interchange. It becomes n rows and m columns. So transpose of A. So A dash will be our transpose. Transpose of matrix A here becomes, so A ijth element becomes A jith element. This is the general term A jith element, and order becomes n cross m. Let us suppose we go to one example. Here is the examples. Let us suppose A is the matrix. It has the order 3. Its element 3, 5, 3, 4, 5, 1, 2 and 7. So now it has two rows. It has two rows and three columns. It has two rows. These first rows and second rows. So if I find the transpose of this matrix A, it becomes transpose of A will be here row becomes first row becomes our first column. So it becomes first column becomes here 3, 4, 5. Earlier it was 3, 1. Now the first row becomes our first column and second row becomes our second column. So therefore 1 to 7. 1 to 7. So it becomes our new matrix known as the transpose of matrix A. So now here order will becomes here 3 rows, first row, second row, third row. Now it becomes 3 rows and 2 columns. So in this way we have interchanged row into columns and column into row. It becomes a new matrix. Order just interchange to each other. So now there are some properties under the transpose. Now properties under the transpose will be here. Properties of its first ones, transpose. If I transpose twice a transpose. If I transpose, first transpose we did, and if I did now this is the first property. If you do again and again, second time I did the transpose, it becomes the original matrix A. And second one, transpose of additions. A plus B, this is the sum of the two matrix. Transpose will be just we do transpose of A and transpose of B. Same way in third ones, if this is the difference of two matrices, the transpose will be transpose minus B transpose. And third ones, fourth one, not thirds. And if K times of matrix A, transpose of K times of matrix A. Here K the scalars, so it doesn't matter, K remain there and A transpose only. Here K the scalar. K is a scalar. Scalar means any numericals value. And fifth one's important, very important properties in the transpose. So here matrix multiplication, transpose of matrix multiplication will be just order changed and multiplied with their corresponding transpose, B transpose and A transpose. So these are the properties under transpose. Next we go some one questions and then symmetric and anti-symmetric matrix. Let us apply property number 1 in this case. Okay, this is already we did the transpose of matrix A. If I again did the transpose of this one, so then it will becomes original matrix A. Now if I do transpose of this one, transpose already did, and again if I did the transpose of this matrix, it becomes again our first row become first column. First row here 3 1 to 3 1, it becomes 3 3 1 first column, and 4 2 is the second row, it becomes 4 2. And third row we have 5 7, it becomes third column. 5 7, you look here, it has two row, first row, second row. So we write this second rows, two rows, and third column. So this is the original. Okay, this is the original one. Again we got this ones 3 4 5 3 4 5 1 2 7. So we can apply very easily the properties of the transpose. So this is the new topic, symmetric and skew symmetric matrices. So this is a very important property in matrices. So here suppose A is a matrix. Here A should be a square matrix. A square matrix. This is a square matrix. If the transpose of square matrix is equal to A, then it is known as symmetric matrix. For this is the condition for the symmetric. So this is the condition for symmetry. If the transpose of A is equal to A, so here A, if I write in the general term, A I jth element and A transpose, suppose it is a square matrix, order n cross n. A the transpose of Aij will be Aji. Aji will be the transpose of Aij. The general terms of the transpose of this ones, it is again n cross 1. So according to these questions, if Aijth element is equal to Ajth element, then it is called transpose of here I and J goes from 1 to n, because it's a element starting from 1 to end at n. So transpose. So here it means that ijth element equal to Ji, then the matrix will be transpose of it. Let us suppose give one examples of this matrix here. Suppose this is matrix A. So here 3 4 and 5, this is the first rows. We are doing order 3 square matrix. So here 4 should be here and 5 should be here, and diagonal element, let us suppose -7, and this is 5 would be 5. So here 2, and this is again 2, and this is 6. This is a square matrix of order 3. So look here. So here this element is good. This element, both are equals. Here 5 and 5 is also equal, and here 2 and 2 is also equal. So it means that so here 4 is the first row, second column element 4, and look here, it is second row's first column element, second row's first row element. And here 5, if I write 5 first row, third column, and this is also this equal to this is the third row and first column, and it becomes 5. So similarly 2 and 2 are the same ones. This is second row, third column, 2 3 element is 2, and the corresponding element is this is third row, second column. This is the third row, second column. So here 2 3th term is equal to 3 2th term. So and diagonals, no change in diagonals. So here in transpose, diagonal element should be the same one, because if I write I equal to J, I equal to, for the diagonals it is 1 1 2 2 and 3 3. I equal to J, it means that there is no change of this ones. According to question, I is equal to I. It means that for the first matrix A11 will be the A11 will remain this one. second row second column element will remain second row element, and third row and will be third row third column element. So there is no change if I do in transpose. Therefore so here the same values would comes for the transpose also. So here the transpose becomes A transpose is again this one A transpose here. So first row 3 4 5 become first column, and second row becomes second columns 4 minus 7 2, third row 5 to 6 5 2 and 6. So to look here, so there is no change in the entries of A dash as equal to A. So that's why the properties said that if the elements corresponding element ith elements of matrix A and jth elements of matrix A dash are equal, then it is called square matrix transpose. Square matrix, yes, it is called a symmetric matrix, not a square. Square is already here, so this is the condition for the symmetric. Now let us do for anti-symmetric, and also known as, this is also known as anti-symmetric and skew-symmetric also. So both will be the same one. Anti, just opposite of the symmetric, known as anti-symmetric matrix. So here in anti-symmetric matrix, the condition for anti-symmetric matrix, skew-symmetric matrix, A transpose A will be A dash. A transpose A should be minus A. Transpose A dash should be minus A. Here if I write a general element of A will be Aij. So this should be also a square matrix. It is possible only for finding symmetric and skew symmetrics. It is possible only for square matrix. So here the ith elements have the order is n. So according to rule number 1, this is equation number first, ijth elements should be minus Aji. So so here the corresponding just opposite of this ones. So now here if I put I equal to j, then it becomes I, both are I minus I. If I put in both the value the I equal to j, now minus Aij goes in left hand side, this becomes 2ai. Ith rows and ith column equal to 0. From here Ai becomes 0. It means that all diagonals elements or entry of a skew symmetric matrix are 0. So here all diagonal elements should be 0. If I write the examples of this one, example of skew symmetric matrix will be, suppose this is the matrix A. Since by this fact AI diagonal elements should be 0 here, so for skew symmetric matrix should be square matrix here. So now all diagonals, suppose if I make a 3 cross 3 matrix, this is about 3 cross 3 0, and this is if I take 4 first row element is 4 and 3, 4 and minus 3, and the diagonal element, so 4 just anti-parallel of this one, 4 should be minus 4 here, and this will be 0, and take any element here. Suppose if I take 7 and 4 minus 4 minus 3, just negative of this one will be 3, and negative of this one will be minus 7, and third entries of this third rows will be 0. So look here, this is a square. Suppose this is a matrix A, its order is 3 cross 3. If I calculate the transpose of this one's transpose, if I find the transpose of this one, it will be if I do transpose of this ones, so it will become 0 4 minus 3. First row become first column, 0 4 minus 3, 0 4 and minus 3, and second row minus 4 0 7 minus 4 0, and this is 7. Third row, this is a 3 minus 7, 3 minus 7 and 0. This is our third row. So look here and compare with if I compares with A dash with A, so it becomes so it is very clear that if I bring minus outside of this one, if I multiply, you bring minus, either you multiply each terms, each entries by minus ones, because minus one in scalar matrix, if you multiply any matrix A, if I matrix A with K is a scalar, then each entry of this matrix, each entry means these are the element, each element should be multiplied by K. So if I bring minus outside of this one, from each entry the minus should come from minus each entry. So here this is 0, and if I take minuses outside of this matrix, it becomes minus 0, this will be plus, and this become plus and plus 4, and this become minus 4, and this is minus 4 will be minus 4, 0 and plus 7, minus 4, 0 and plus 7. Here this will be negative of this one is 3, negative of this will be minus 7 and 0. So if I look this expression will be the same as matrix A. So we can write it minus A, transpose of A will be minus A. So this is for the case of the skew symmetric matrix. Now let us do some properties of skew symmetric matrix and symmetric matrix. There are many properties, very important properties here. Let us do. Yes, some properties of these two matrix properties here. First one, A is a square matrix. A is a square matrix. Then A plus A plus transpose of A dash, A plus transpose A will be symmetric matrix. And A minus A dash will be our A minus A dash will be our skew symmetric matrix. Is skew symmetric matrix. Yes, how it becomes skew symmetric? If I transpose of this one, according to, for the skew symmetric matrix, we have to take the transpose of this one by the properties of a transpose of it become transpose of A minus, this is double transpose. Double transpose will be our original matrix A. So this become our original matrix A minus A. If I take minus outside of this one, so minus A becomes positive and this one. So this is our original matrix. So A minus A dash. So that's why transpose of A minus A dash will be our skew symmetric matrix. And in case of A plus A dash, if I take the transpose of A plus A dash using the properties of transpose, now it becomes transpose of A plus transpose of A. So this is the original matrix. So that's why A plus A dash will be our symmetric matrix and A minus A dash will be our skew symmetric matrix. Now second property is any matrix can be written, any square matrix can be written as a sum of symmetric matrix and skew symmetric matrix. Therefore any square matrix will be sum of symmetric matrix plus skew symmetric matrix. Skew symmetric, this is very important property. Skew symmetric matrix Suppose take an examples A. AI is the square matrix. Aij element is square matrix of order is n, and cross n known as square matrix. So we can write this as A. If I write twice A and divide twice A by 2. So now half like right half like this one. This is adding this is A plus A. Twice A means A plus A, and we can write A replaced by A plus A transpose, and A also if I adding A transpose, we should also subtract minus of the transpose. So right in this bracket, this is second bracket. So if I split this one, half A plus A dash, this is our symmetric matrix, and the next one half A minus A dash will be our skew symmetric matrix. In this way I have written this. So A this will be symmetric and this will be anti-symmetric matrix. So here this will be symmetric matrix, and it will be skew symmetric matrix. So in this way, any square matrix can be written sum of symmetric matrix and skew symmetric matrix. So here half A plus A dash is the symmetric, and half A minus A dash will be skew symmetric. Skew symmetric. We have using this here by the properties of equation number property number 1, A plus A A plus A dash will be skew symmetric, and that's why A plus A dash is symmetric, not skew. This is a symmetric. 1 by 2 doesn't matter because 1 by 2 is a scalar, and here A minus A dash is skew symmetric. So that's why half A minus A dash will be our skew symmetric. So half is a scalar. Okay, it doesn't matter because in the properties earlier we did, suppose if A matrix is multiplied with A scalars, and if I take the transpose of this one, so K transpose, K is the real numbers, so K transpose will be K. There is no effect of the multiplication, taken the transpose of any scalars. So these are very important properties under symmetric and skew symmetric, and let us do some numericals on these properties